Group 7 Laboratory 3 Demonstration. In this lab exercise, our group explored the basics of Arduino input and output. We aim to understand how to interface sensors and actuators with the Arduino board and how to control these components through programming. This foundational knowledge will be crucial for developing more complex projects and applications using microcontrollers. Program 1A. This program blinks an LED connected to pin N of the Arduino. It sets the pin as output in the setup function. The loop function toggles the LED state every 0.5 seconds using digital write and delay. So, first, we need the breadboard and the Arduino board. We need an LED and connect it to the breadboard. We also need the resistor with 220 ohms resistance value. We're gonna connect it to the positive side of the LED and to pin 8 of the Arduino board. Now we're gonna put in the sketch for the program and test it. Now it's blinking every 0.5 seconds. Program 1B sequences 3 LEDs in a loop, each turning on for 1 second and then turn off. Use an array to store LED pin numbers and a nested loop to repeat the sequence 10 times. So we need 3 LEDs and 3 resistors with 220 ohms. We need to connect the negative side of the LED to the ground of the breadboard. First one and the second one, now the third one. Now we need to connect the positive side of the LED to the resistor and then the pin of the Arduino board. Now we're gonna connect it starting from pin 0. Now pin 1 and pin 2. After that, we're gonna put the sketch in for the program to work. It should light up in sequence, like so. Program 1C. This introduces a custom blink function to blink an LED a specific number of times. So the LED will blink for a specific number, like so. We reuse the previous board and change the sketch only. Program 2. Connect a red LED to pin of the Arduino and blinks it on and off forever. The delay will be 0.75 seconds. So connect the negative to ground and the positive to the Arduino pin. So pin number 0. Now it's time to put the sketch in for the program. As you can see, the delay is 750 or 0.75 seconds. Program number 3. This one alternates between 2 LEDs connected to pins N and N+1 with the same delay, which is 0.75 seconds. So we're gonna connect it to ground again, the negative side, and the positive to pin 0 and pin 1. And then we're gonna put the sketch in and start simulation. As you can see, it alternates between the 2 LEDs for 0.75 seconds. Program number 4. This is a traffic light. It simulates a traffic light using 3 LEDs, green, yellow, and red, connected to digital output pins. Each LED stays on for a predetermined duration, mimicking the behavior of a traffic light. So the green is set to be in 10 seconds, the yellow in 1, and the red for 8. We're gonna connect the negative to ground the breadboard and the positive to the Arduino pins, starting from 0 to 2. The green is on 0, yellow is on 1, and red is on 3. Now put the sketch in and start simulation. The green should turn on for 10 seconds. Turn off the yellow for 1 and the red for 8 seconds. And then it will repeat. Program number 5, the last program. This creates a menu-driven running light effect controlled by 5 toggle switches or push buttons. This displays a menu on a serial monitor and executes different light sequences based on the selected option. So on this one, we need 8 LEDs, 4 red LEDs, and 4 green LEDs. We need 5 switches for the 5 option on the serial monitor. So we need to connect the breadboard to the ground of the Arduino. Also, the 5 volts of the Arduino will be connected to the positive side of the breadboard. After doing so, we're gonna set the 8 LEDs on the breadboard. Then, the later 4 will be color green. Then we're gonna need 5 push buttons. We're also gonna need 8 resistors for each of the LEDs. Then we're gonna connect the LEDs to their respective ground. We're also gonna connect the push buttons to their respective grounds. Then we're gonna start connecting the positive side of the LED to the digital pins of the Arduino, starting with pin 2. Then the second LED. So we connected from pins 2 up to pin 9. Then we're gonna connect the switch or the push buttons starting from pin 10 until pin 13. Now the pins are full, so the last push button will be connected at the bottom pin A0. Now this is the board we're gonna put in the sketch. We're gonna put in the sketch of the program and start the simulation. As you can see on the serial monitor, there is a menu. So by clicking the switch number 1, a particular sequence is done. Now sequence number 2, and then sequence number 3, sequence number 4, and now sequence number 5. Buttons 1 to 4 will set the state of the LED and button 5 will save the step. There will be 5 steps, and after setting it, the steps will be shown by sequence on the LED.